Good morning students. Today we will discuss about bipolar junction transistor. This can also be called as BJT. This is represented as BJT. B bipolar, J for junction and transistor, T for transistor. Bipolar junction transistor. Now see here, bipolar junction transistor. It is having three terminals. It is a three-terminal semiconductor device. See here, if I take PN junction, PN junction is having only two terminals, P terminal and N terminal. But whereas in bipolar junction transistor, it has three terminals. Next, here in PN junction, there will be current due to minority charge carriers, or otherwise it will be due to majority charge carriers. But in bipolar junction transistor, here current is due to interaction between both majority and minority charge carriers. So that's why it is called as bipolar junction transistor. Now here this BJT, bipolar junction, is a current control device. Means the output depends on the input current. So BJT means it is a three-terminal device. Next, here current is due to both interaction between majority and minority charge carriers. Next, it is a current control device. Now we'll go for construction of bipolar junction transistor. How to construct a bipolar junction transistor? Now here junction transistor, bipolar junction transistors are divided into two types. They are divided into two types. One is NPN transistor and another one is PNP transistor. Here NPN transistor means in between N-type semiconductors, if we place a P-type semiconductor, means P-type semiconductor is sandwiched between two N-type semiconductors, then it forms NPN transistor. If N-type semiconductor is placed in between two P-type semiconductors, then we call it as PNP transistor. Now NPN transistor. So see here we have seen a transistor in which two blocks of N-type semiconductors are separated by P-type semiconductor. It is called as NPN. If P-type semiconductors, see here, if N-type semiconductor is placed in between two blocks of P-type semiconductor, then it is called as PNP transistor. Now, transistor terminals and junctions. Transistor terminals and junctions. So how many terminals it has? BJT has three terminals. How many junctions it has? It has two junctions. So it has three terminals and two junctions. So the three terminals are, one is emitter. First one is emitter. What is an emitter? So see here, this emitter is more heavily doped. Here emitter region is heavily added with impurities. Than any other region, these are added with impurities. See here, the main function of emitter is to supply majority charge carriers to base. So the function of emitter is to supply majority charge carriers to base. Next, emitter region is heavily doped. Next terminal is base. So base, it forms the middle section of the transistor. So it will be at the middle of the transistor. This base layer is made very thin. The base layer is very thin. It is of 10 power minus 6 meters when compared to emitter or collector. When compared to other two regions, this base region is very thin. So what happens is here, what is the function of base is the carriers are coming from emitter to base. These carriers should be sent to collector. So the main function of base is it has to receive charge carriers from the emitter and it has to send it to collector. So for that purpose it is very lightly doped. So what is base? It is very thin, it is made very thin and it is very lightly doped. It forms the middle section of the transistor. Next, its main function is it has to collect the charge carriers from the emitter and it has to send it to collector. So this is the main function of base. Next one is collector. What is the main function of collector? So see here, the main function of collector is to collect majority charge carriers coming from emitter and passing it through the base. Okay, so from the base it need to collect charge carriers from the base. So it is moderately doped. How it is doped means it is moderately doped. It is lightly doped and it has large area when compared to emitter region. When compared to emitter region, collector region is having large area. Okay, because much heat is produced here which can be easily dissipated, which can be easily removed due to large area. So what are the three terminals of transistor? One is emitter, another one is base and another one is collector. Emitter is heavily doped. Its main function is to emit charge carriers to the base. Next one is base. Base is made very thin. It forms the middle section of emitter and collector. It is lightly doped. Its main function is to collect charge carriers from emitter and it need to send it to collector. Next, the main function of collector is it has to collect majority charge carriers from the base which is coming from the emitter. Next, it is moderately doped and it is having large area when compared to emitter and base because here heat dissipation is there. In order to avoid that, we have large area. Now, so see here how many junctions it have. How many junctions it have. So see here, if we go for PNP transistor, so here this is the P region and this is N region and this is P region. For PNP transistor, this P forms the emitter. Next, this forms the collector. Emitter, collector, and this is the base. This is the base. Next, see here, if I form NPN transistor, so NPN transistor, this is the emitter and this is the collector and this is the base. Now it consists of two junctions. One is emitter base junction which is called as emitter junction. Next one is collector base junction which is called as collector junction. Now emitter base junction. So see here, this is the emitter base junction. Now emitter has to send charge carriers into base. Charge carriers into base. So it has to send charge carriers into base means it should enter into PN junction. So which bias I need to apply? I need to apply forward bias. So forward bias means for N type it should be connected with negative terminal and P type should be connected with positive terminal. So what happens? What are the majority charge carriers here? Electrons. So what happens? Negative repulse and this electron move towards base. So it should be of forward bias. Next, base should be very thin such that it takes only these charge carriers and send it to collector. So here this emitter base junction, this is emitter base junction, which is also called as emitter junction, it should be always forward biased. Next, collector base junction, it need to collect the charge carriers, no need to develop any charge carriers, so it should be reverse bias. It should be reverse bias, means p type should be connected to negative terminal and n type should be connected to positive terminal. So it should be reverse bias. This is collector base junction, which is also called as collector junction. So these are the two junctions of the BJT. Emitter base junction should be always forward biased and collector base junction should be always reverse biased. Okay. Now transistor symbols. So if we go for transistor symbol, so see here transistor symbol, if it is NPN transistor, the symbol is, it is NPN transistor. So this is the base and this is the collector and this is the emitter. This is the collector and emitter. So the arrowhead represents, see here, emitter is shown by an arrow which indicates the direction of flow of conventional current. Next, here for PNP transistor, if it is PNP transistor, so this is the base and this is the emitter junction and this is the collector junction. So the arrow, one is emitter junction, this is the emitter junction, so emitter junction. So this is for NPN transistor and this is for PNP transistor. Okay. So the only difference between NPN and PNP transistor symbol is direction of arrowhead placed on the emitter. So that is the difference between the NPN and PNP transistor in their transistor symbol. In their transistor symbols you can see here. Next, if we go for principle of operation, means its working. Now we will see the working of NPN transistor. So this can be discussed in the next class. So the operation of BJT can be discussed in the next class. Thank you.